Most observability platforms are always talking about speed.
Right. How fast can you get your data? How quickly can you deploy?
Exactly. But today we're doing a deep dive into Datadog, one of the world's most critical infrastructure monitors. And for them, the real focus has shifted
It's moved from speed to safety.
to safety. And we're going to unpack how they're using OpenAI's coding agent, Codex, to prevent those huge system-wide failures that, frankly, scare every senior engineer.
Yeah, the mission here is really to understand how AI has moved beyond just, simple mistake catching.
Like a fancy linter.
I'll make a very fancy linter, yeah.
Yeah.
It's to get more of a system-level guardrail. It's there to protect customer trust by stopping those catastrophic incidents before they happen.
And the stakes for Datadog are just enormous. I mean, their reliability has to be non-negotiable.
Of course, customers rely on them precisely when their own systems are breaking.
So in the past, catching those really systemic risks, that all fell on senior engineers, right? Because the old pools, the static analyzers, they were just too noisy.
Oh, completely. They'd give these shallow suggestions that were just easy for engineers to ignore.
Right.
And that's really why they failed. They just couldn't grasp the deep context. So Datadog's AI DevX team, they brought in Codex because they needed something that could provide true system-level reasoning.
Something that could surface risks that a human just can't hold in their memory at that scale.
Okay.
Okay, so let's unpack that. What makes Codex so different?
Well, what's fascinating is how the underlying large language model just changes the game entirely. A linter looks at syntax, maybe some known bad patterns. Codex, it sort of holds the full architectural map in its memory while it analyzes a change. It compares the intent of a pull request with the code itself,
And it's reasoning over the entire code base.
the entire code base and its dependencies. An engineer there said it was, and I'm quoting, the first one that actually seemed to consider the diff in the larger context of the program.
Wow. That is an incredibly high signal feedback. It almost sounds a little scary for an engineer who's used to working solo.
I think it's more like it's lifting a massive mental load. Engineers described a comment from Codex as feeling like, and this is another great quote, the smartest engineer I've worked with and who has infinite time to find bugs.
Infinite time to find bugs. That says it all, really.
It really does. I mean, the AI was pointing out dangerous interactions with modules that weren't even touched in the code diff.
Things a human reviewer might easily miss.
Easily miss. Or identifying missing test coverage in really tricky areas of cross-service coupling. Things that carry massive downstream risk.
Okay, so the feedback is high signal. But, I mean, you can't just take the AI's word for it. How did they actually prove that this system works against, real-world chaos?
They needed proof. So they developed this really clever process called the incident replay harness.
A time machine, basically.
It's essentially putting the AI in a time machine.
Yeah.
They would reconstruct pull requests that had historically led to real incidents, and then they'd run Codex against them.
As if it were there for the original code review.
Exactly.
So what was the outcome? What did they find? That's the bottom line.
And this is the core insight for you. Codex found more than 10 cases, which is roughly 22% of the incidents they examined.
22%.
Yep. 22% of cases where human experts had already approved the code, but later confirmed that the AI's feedback would have absolutely prevented the failure.
So it's not replacing the human. It's complementing them.
It's a new high-fidelity safety net. It's catching things that humans, looking at an isolated change, often missed. The other 78%, well, those required the kind of big architectural trade-offs that only a human can make.
Right. But proving the concept with that success rate is huge. And now over 1,000 engineers are using it regularly.
That's right. And it's fundamentally changed what code review even means at Datadog. It's not about speed or just catching errors anymore.
Which is where this gets really interesting. The focus shifts to risk and reliability.
It does. And it lets the human reviewers focus their energy on those higher-order tasks.
Architecture, design, those complex trade-offs you mentioned.
It's a fundamental change, establishing AI as a core reliability partner.
So what does this all mean for you listening? The takeaway is pretty clear. AI isn't just a linter anymore.
Not even close.
It's becoming a fundamental reliability system. It's what allows a company like Datadog to ship changes quickly, but more importantly, safely. It's about solidifying that customer trust.
It's all about increasing confidence at scale.
So here's something to mull over. If AI can consistently find these critical flaws, these edge cases that even expert humans struggle to see in isolation, what is the next critical task for the senior engineer? What's the one thing that AI can never automate? Something to think about until the next deep dive.